In this lecture, we will study particle accelerator, specifically cyclotron. Just to revise, we are studying the effect of electric and magnetic field on the charged particles. We are studying application of this effect on charged particles by electric field and magnetic field. We have discussed one application, mass spectrograph, in the previous lecture. Now, this is another one. As it is clear from the name, it is used to increase the velocity of particle. It's called accelerators. In this lecture, we will study basics of accelerators, the principle behind the accelerators, then types of accelerator, linear, metatron, cyclotron, then linear basics and applications, then cyclotron, its basic principle, construction and working, and finally the applications. Particle accelerator, as clear from the name, it is used to increase the velocity of particle. That's why we will study how the velocity of particle can be increased here. Particle accelerator, as it is clear from the name, accelerator means it is used to accelerate the velocity of the particles. Here we are talking about particles means small particles, maybe neutron, proton, electron, alpha particle or some other particles. We generally, in many applications, we need high energy particles, high velocity particles. If we want to perform many nuclear reactions, we want high energy particles. If we want to study what is happening in nucleus, then you have to bombard the nucleus with high energy particles. And the energy or the velocity is limited at the time of creation of the particles. If we want a required amount of energy or velocity, then we use particle accelerator device. The device which impart such energies are called particle accelerators. Generally, two types of particle accelerator were developed in 1931 and 32 and named as linear accelerator and cyclic accelerator. As it is clear from the name, linear means in which we increase the velocity or energy of the particle by moving the particle in linear direction. In linear accelerator, all the time particle move only in linear direction. While in cyclic accelerator, we rotate the particles so that it can get energy, increase the velocity. In linear accelerator or linear, a charged particle accelerate in a straight line in which we keep a series of cylinders. And see this. These cylinders are of different lengths. The length is increasing continuously. Smaller, then bigger, then bigger, then bigger. You just observe this length. This is this length only, then the bigger length, then even bigger length, and then even bigger length, and so on. We are keeping gap between these. A series of accelerator step in current phase as a series of gap between this. Here, the source is shown here. The source gives you ions, move here. One also this is minus, this is plus, this is minus, this is plus. Suppose your ion is plus, then This is minus. It will attack toward this. Then it will be passed through this. Again, this will be minus. Then will pass through this, and this will accelerate in this way. Finally, move to target here. This here should you have target. In a linear accelerator, the moderator accelerator potential is applied a number of times so that the charged particles are accelerated along a straight line. I am ignoring mathematical part of this because it is not written specifically in your syllabus. But at least we must know the qualitative part. The limitation of this accelerator is the length of accelerator become inconveniently large. So continuously, if you continuously increase the length become large, and it becomes difficult to maintain vacuum in such a large chamber. The ion current is available in the form of pulses. This is another thing. Due to this limitation, we move to another one. A cyclotron at its term, it is a cyclic means rotation, something is in a cyclic motion. The basic principle is charged particle moving in a transverse magnetic field. Transfer means the particle is moving. When particle is moving, we are applying magnetic field perpendicular to that. And we have already discussed in the previous lectures, when we apply perpendicular magnetic field, this will describe a circular path of your particles. And the frequency of the revolution of the particle is given as this. It is seen that the frequency is independent of the particle velocity and hence its kinetic energy. The slower the particles will move in a smaller circles and vice versa, so as to take same time to complete one revolution. Hence, charged particle having different initial velocity can be accelerated to produce high energy beam, even by moderate potential difference. The energy has to go through the electric field due to action of uniform magnetic field. The particle gain a small amount of energy in each cycle and finally energy will be gained. The condition is frequency of the revolution. First it will move in the first, then it will move in the second, and independent. You can get the energy gain. In this cyclotron, a short cylindrical hollow metal box is cut into two halves along a diameter. It is shown, the top portion is shown here. This is first half and this is second half. The resulting semicircular chamber resemble like D. These are two Ds now, and hence is termed as TEES, Ds. The Ds are separated by few centimeters from each other and constitute the electrodes. They are insulated from each other and are enclosed in a vacuum chamber. The power magnets produce a magnetic field perpendicular to direction of velocity of the electron. A high frequency oscillator is connected to the Ds, which establish electric field between the gap. This is there here, shown here. The frequency order first, this is if this first D is plus, then the second is minus, first D is minus, second is plus, and so on. An iron source is located near the center of D. The schematic is shown here. Iron source, you can, if you want to see iron source, I am just and circling this. This is here inside this circle, ion source. Now the ion will be initiated from here, then will rotate in this. As the energy gained, it will move to bigger circle, then bigger, then bigger, then bigger, and finally it will deflect from here. It will come out from here. We have discussed this here. Just revise this. How it is generating charge particle. Suppose particle, then initially the first is negative, so it will move inside the first D. Inside the first D, it will take circular path. Why it is taking circular path? Because due to magnetic field, perpendicular magnetic field is there. Then when it comes out, second is negative, so it will attract toward the second. Then again, then again, then again. Finally, each time while the velocity, why it is spiraling in the outward direction? Because velocity is increasing. And continuously the particle is moving from D1 to D2, D2 to D1 and so on. We have maintained the frequency by using high frequency oscillator here. And finally, emerging beam you will get. We can discuss the working. Suppose the ion source emit positive charge ions and at the same time the D is negative. If the D1 is negative, the ion will attract towards D1. The electric field is mainly concentrated across the gap and negligible in the Ds. So, as it moves inside the D, no electric field will be observed, but it will deviate from their path due to transfer magnetic field. And the time period of the ion magnetic field can be calculated as T is equal to 2 pi m over qb. We have seen how time period can be calculated in the previous lectures. Actually, time period is a time, so time is equal to distance upon velocity, 2 pi r upon b upon v, and in that v you can write down the value. I can, for your help, I can write the formula here also. 2 pi r upon v. Now here you can put the value as we obtained. As we know this, if the particle is moving in circular direction, you have this formula, mv square upon r. This should be equal to q v b. From here you can calculate the value of r and put it here. You will get, if you put these two values here, you will get this. So how you can calculate time period now? If you maintain this, then so the ion arrive the gap between the days, completing half the revolution in time t by 2, and if the frequency f0 of the oscillator is adjusted such that the ions reach the gap, the potential in the Ds get reversed and now D2 is negatively charged. Again, now the particle attracted towards ion attracted towards the second D. In this revolution, the ion gain energy 2 QV. When V is applied by the oscillator, as the ion gain energy, their velocity increase, the radius of charged particle depends on velocity, so the velocity radius will also increase, and it will circulate with different radius. So in each revolution velocity increases and will create next circuit. After about 100 or more revolution, the ions acquire energy of the order of MeV, mega electron volt. At the end of the journey, the ion beam passes through a narrow slit in the side wall of the disk and moves through DC electric field constituted by Ds. The emerging beam is used to bombard on a target under study. The maximum velocity obtained from the cyclotron can be written as this: Vm is equal to QB upon M. We did this using R is equal to mv upon qb. And so if you know the maximum velocity, we can calculate the maximum kinetic energy also, half mv square. This energy can be obtained using a particular values. If you know the value of q, it is known, m is known, applied field is known, then just by calculation of R, you can get the idea the what maximum velocity can be obtained, maximum energy can be obtained in this case. You can't say it is the final cyclotron accelerator. Many new accelerator already been discussed. It is seen that the oscillator frequency is given by f0 qb upon 2 pi m. If this is the RTF frequency, then higher the cyclotron frequency, stronger the magnetic field needed. This result in increase in the maximum energy of the ions. But there is a limit of maximum strength of magnetic field that can be produced. And hence, there is an upper limit of energy of the ions. So this is limited by magnetic field B. This is one. Second, can you guess? Yes, whenever we talk about velocities, high velocities, we have to take care of relativistic variation given by Einstein. If you move to a very high velocity and your velocity is closest to velocity of light, you have to see problem arises due to relativistic mass. As we know, the mass should be considered in that high velocity, not m0, but m0 over 1 minus v square by c square. If you take this, then the time period of the particle become 2 pi upon qb m0 to 1 minus v square by c square. It means if the velocity increases, the time period will vary. Time period will increase. So the particle will come out slightly late than the previous one. If it comes slightly late from NED, this will also change your frequency behavior. And so it is difficult to accelerate the particle after a certain limit. This will increase the value of the velocity. The time period required to reach the gap increase. Hence the ion lag behind the applied oscillator voltage, result in stopping acceleration of the ions. To prevent such a condition, the ion frequency is kept constant by maintaining the value of B under root 1 minus V square upon C square constant. This is the solution for this. So you have to maintain the frequency constant somehow. You have to change the B. This is another type of cyclotron that is called synchrotron. For electron, there is again an issue of small mass. Mass is small, so immediately get the higher energy and difficult to accelerate them. For which we have different cyclotron, different accelerator that is called betatron. So we have discussed many accelerator here. Cyclotron is useful for exam point of view. I suggest do some numericals also, in which Q is given, V is given, mass is given, and calculate radius or calculate energy, maximum energy can be obtained. This type of numericals can be seen on your textbooks, RP Goyal or Engineering Fields by Shir Sagar, whatever you suggest. Thank you.